Hello, my name is Samara, and today I'll be walking you through the process of metal foundries. We'll discuss how metal foundries work, their hazards, control measures, and regulations to protect workers and the environment. By the end, you'll have a solid understanding of the safety considerations and regulations associated with foundry operations. Here are the references I used for this presentation. You'll see that a lot of them are either NIOSH or OSHA. This presentation will cover an overview of metal foundry process, products made in foundries and their applications, hazards in the process, a chemical hazard associated with the process, control measures to reduce the chemical hazard, and relevant regulation at both state and federal levels. So let's start with an overview of the process. The metal foundry process involves multiple stages. First stage, you'll have the charge preparation and melting. So scrap metal and ingots are melted with flux to form alloys. You'll have a sand and core preparation, which sand molds and chemical binders are prepared for shaping. You have molding and pouring. Molten metal is poured into molds and cooled to form solid castings. You have shakeout and cleaning, where castings are removed from molds, cleaned, and finished. And then you have sand reuse, where sand is processed and recycled for future molds. Each step is interconnected, minimizing waste while ensuring precise manufacturing. Here are photos illustrating foundry operations, such as sand molding, molten metal pouring, and cleaning metal. Foundries produce cast metal components used in automotive parts, such as engine blocks and brake discs, industrial equipment, such as pumps and valves, and construction materials, like structural components and pipes. These products are integral to industries worldwide, highlighting the importance of safe and efficient operations in foundries. Workers in foundries face several hazards, such as chemical hazards, where they can be exposed to heavy metals like lead and cadmium. They can be exposed to fumes from molten metal, and they can have exposure to silica dust from sand. While biological hazards may be rare, they can include mold contamination. In physical hazards, you can have heat stress from molten metals, you can have a risk of burns and fires, and then noise. In ergonomic risks, you can have heavy lifting and repetitive tasks that can lead to injuries. Understanding these hazards is critical to implementing effective safety measures. The hazard that I'm going to focus on today is silica dust. Silica dust is created during sand preparation and shakeout. OSHA limits exposure to 50 micrograms per cubic meter over an 8-hour workday. When silica is inhaled, some examples that it could cause is silicosis, which is a severe lung disease, as well as it can increase the risk of lung cancer. In the video to the right, you'll see when you inhale particles, that even when you exhale, some of the particles do not go out of the lungs. To protect workers, the following controls should be implemented. With engineer controls, you can use water to suppress dust generation at the source during operations such as cutting, drilling, or grinding. You can use general ventilation systems to dilute and remove airborne dust. You can enclose high dust generating processes to keep silica dust contained and prevent it from spreading to other areas. And you can replace silica containing materials with less hazardous materials where it is feasible. With administrative controls, you can educate workers on the hazards of silica dust, proper usage of controls, and the importance of safety protocols. You can rotate workers to limit the amount of time each individual spends in areas with high levels of silica dust. And you can monitor regular air to measure silica dust levels to ensure they are below permissible exposure limits. With personal protective equipment, or PPE, you can use NIOSH-approved respirators like N95, P100, or PAPR to filter out harmful silica dust from the air. You can wear safety goggles or face shields to protect the eyes from silica dust. And you can use overalls or other protective clothing to prevent silica dust from coming into contact with the skin. Issues with controls could be the cost, the maintenance of the ventilation systems, and worker compliance with PPE use. Metal foundries are regulated by state and federal standards. So while silica doesn't have a specific regulation in the state of Montana, they do have the mining license tax, which applies to metal processors. And then Montana's DEQ enforces air quality and hazardous waste rules. Then you have OSHA standards, one for silica, which limits exposure to silica dust. You have hazard communication, which ensures worker awareness of hazards like silica, lead, and cadmium. You'll see the hazard pictogram to the right as a health hazard pictogram, which is applicable to silica. Then you have a respiratory protection standard, which specifies respirators required for hazardous tasks. I've linked both of the OSHA standards for silica and respiratory protection. With EPA regulations, they help control emissions under the Clean Air Act. Compliance ensures safety for workers and the environment. Let's recap what I've covered today. Metal foundries involve complex processes that are critical for manufacturing but can pose significant hazards. Silica dust is a chemical hazard that can have health risks if not controlled. Effective controls, including ventilation and PPE, are essential for worker safety, and compliance with OSHA and other regulations ensures safety and legality. To wrap up, here are two multiple-choice questions. Which of the following is a hazard found in metal foundries? And what is the OSHA permissible exposure limit for silica dust? Thank you for listening, and I hope you have a good rest of your day.